Hey guys, this is your example problem on roller coasters. As you can see right down here, we have a roller coaster labeled with three positions. Position A at the top of the first hill, position B at the bottom of the first hill, position C at the top of the second hill. On this coaster, you've got 50 meters tall for position A and 20 meters tall for position C, but position B is at ground level, so there's no height to it at all. Like most coasters, when we didn't show like the lifted up part where the cart gets lifted up to the top at position A, where it starts, but it basically starts with no speed, so it starts at rest. You could write for position A. All right. So that's a key. That means that the velocity is 0, right? So we could fill that in there. In fact, right down there, say velocity is 0 meters per second to start with. And I want you to solve for basically four things at every position. I want you to solve for kinetic energy, gravitational potential energy, total energy, and velocity at position A, B, and C. All right. So we're going to start with letter A. All right. At letter A, you've got a height of 50 meters, so you could use that to calculate your GPE. All right. Remember GPE. I'm going to do all my calculations down here equals mass times gravity times height. And we got to give you a mass to the coaster. We got a mass, let's just say 100 kilograms. Alright, will be our mass. So 100 kilograms times 9.8 times the height is 50 meters. And type that in your calculator right now. And you get 49,000 joules of GPE. It's a heavy coaster, so there's a lot of energy. Joules is the unit for energy. Capital J. Alright, so here if it starts at rest and there's no velocity, we could use the KE formula if we want. But even if you look at that, sorry, went off screen a little bit. If you look at that, there's your GPE calculation. If you plug in a velocity of 0 right there, then there's going to be no kinetic energy. So you could pretty much plug in a 0 for kinetic energy when there's no velocity. Your total energy is the sum of KE and GPE. Alright? So your total is going to be 49,000 for the GPE plus 0 for the KE, which is just still 49,000 joules. Now, what do we know about total energy? We know that in the absence of friction, which we're going to assume there's no friction here, that it stays the same. So we know that 49,000 is our total energy at all locations, right? Great. So let's continue with letter B then and kind of start filling out letter B. We know at letter B we're at ground level, so there's no height. What does that mean? That means we have plenty of kinetic energy there, but no gravitational potential energy because we're at ground level. All right. So therefore, all of its energy is kinetic. All the total. How do we get the 49,000? Well, it's 49,000 plus 0 again, but this time the 49,000 isn't GPE, it's KE down here at ground level. All right. So now we got to calculate velocity using the KE formula. There's your formula. Kinetic energy equals a half mv squared. Plug in your 49,000 for KE. A half, 100 is the mass. V squared. What's a half of 100? It's 50. And you could divide both sides by 50. On the left side, 49,000 divided by 50 gets you 980. And you could take the square root of 980 and you get the velocity. Do this on your own calculator just to practice. Alright, so you get 31.3 meters per second. It's the velocity. So at ground level, all of your energy is kinetic. and you could just use that to calculate your velocity. Now, letter C, you're not at ground level. So you're moving, so you have some kinetic, but you also have height, so you have some gravitational. If you have that case where you're kind of in between your highest point and ground level, just calculate GPE first. Alright, 100 times 9.8, and your height here is 20 meters. So your GPE comes out to 100 times 9.8. Do this on your own calculator as well. (19,600) joules. So you just use the height to calculate that. Now, how much KE do you have? Well, KE is the sum of GPE and total energy. So that looks like this. If you add together GPE and KE, you get your total. So we just calculated our GPE is 19,600 and our KE is 49,000. Oh, no, sorry, not. Eraser time. There we go. Our KE is what we're looking for. Alright. And then our total we know is 49,000. So what's our KE equal to? Well, if you take the 49,000, you subtract 19,600, and you get your KE is equal to the difference of those two numbers, not 29,400. So those two just need to add up to make total energy. Alright. Finally, to get velocity, you're going to use your kinetic energy, and I'll do that right over here. Alright. So your KE is a half mv squared. You could plug in your 29,400. Right? Zoom in right there. You could plug in your 29,400 equals a half 100 v squared, right? There you go. Half of 100 is 50. And now we could get our velocity. 29,400 divided by 50. Do it on your own calculator. 588. Now we're not done. Remember, we always need to take the square root of both sides before we find our velocity. Alright? So that would be, make your velocity 24.25 meters per second. So basically, once you find your KE, you can use it to get your velocity. Just plug it in there and solve for V. Alright? Alright, there you go, guys. There's your example problem for coasters. Alright? Go through that with me. You listen to it again if you need to. And then, good job.